Hello, parents and teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy. And in this video, I'd like to continue our look at number sense, and in particular, just types of numbers your children may be learning about. Now, when I learned about odd and even numbers, square and prime numbers, I learned it more through a rule-based approach. And your children may be learning it that way. I learned the rule that if a number ends in 0, 2, 4, 6, or 8, it must be even. 1, 3, 5, 7, 9, it must be odd. And so it's very numeric. Square numbers was a number multiplied by itself, or two factors, right? 3 times 3, 5 times 5, 7 times 7. And then prime and composite numbers we learned about. And it was all very numeric, as I said. But I hope you'll see in today's video that looking at the geometric side of it might help your children build more of an understanding, that conceptual understanding side of the 5 strands of math proficiency, not just a recall approach. So we're going to look at types of numbers, part of number sense, and we're going to start with odd and even. Now, if you've looked at any of the other videos that I've done, you would have seen this 10 frame. It's a very common image, a common model we use with young children. Sometimes we tend to leave it around grade 1, but it really helps us in grade 2 when we start to look at odd and even. And I hope you'll see it'll help your children as they move up through middle school start to understand some of the images and some of the problems they might be asked to solve there. So we start with the 10 frame, and then we're going to look at partial 10 frames. So I've just removed some of the squares off of the 10 frame, and you can see that these go backwards in order from 10 to 1. Now, if we isolate the ones who all have partners, right? The numbers where there's always partners, you'll see we'd be left with 10, 8, 6, 4, and 2 have a partner. And we can define that as being even. They're always a partner. But we ask your children other things they know. They're all doubles. As they move up through the grades, we talk about 2n. One of the factors of every even number will be 2. It's always a double, 2n. Okay, if we look at the ones that have an extra, have somebody kind of standing alone, those are our odd numbers. 9, 7, 5, 3, and 1. Now, if you look at those, notice it's a double plus 1, like 9, double 4 and 1 more, or a double minus 1, double 5 and 1 fewer, minus 1. 7, double 3 and 1 more, or double 4 and 1 fewer. So each of these can be expressed as a double plus 1 or a double minus 1. And as they move up through the grades, they need to understand that all odd numbers could be represented as 2n plus 1 or 2n minus 1. Now, there are problems that they get as they move up in the grades that are things like, find 3 consecutive odd numbers with a sum of. Now that's where I started to get tripped up because I knew what odd numbers ended in, but I didn't have the understanding of 2n plus 1 or 2n minus 1. Now see, think about, do you see the double there? See, double 2 and 1 more is 5. So 4, double 2 and 3 more, double 2 and 5 more. 3 consecutive odd numbers, 2n plus 1, 2n plus 3, 2n plus 5. The imagery helps us build that understanding so we can use it to solve problems later. So think about how important these pictures are to help your child generalize, apply, use later. Now, here's our doubles, right? What are 3 consecutive even numbers? 2n, 2n plus 2, 2n plus 4. Same idea, okay? Now, think about square numbers, right? We have a square. We could have a 1 by 1, a 2 by 2, a 3 by 3. See, now I said I learned it numerically. A number times itself. And I didn't link the language of square to actually the area of a square. Square number, so we have side lengths of a square. Now that's embarrassing at this point. But as a young child, I didn't make the connection. Square numbers made squares. They were the side lengths of the squares. Now, once I understand that, that helped me also have a geometric idea of what square roots were. Squares, when you square a number, it's when you know the side length and you find the square's area. Square root is when you know the square's area and you have to find the side length. It gave me a very nice connection between square root and squares, and we can do it geometrically. Now, prime, if it's not prime, it's composite, or maybe neither, right? But if you look at prime numbers, an activity that I often do with children to help them see the geometric look of prime numbers is I have them draw all the rectangles they could make with 2 squares, 3 squares, 4 squares, 5, 6, 7, up to about 12. And we let the vertical and the horizontal orientation be considered different. So you can see a way I could draw rectangles, must be rectangles, using 2 squares, 3 squares, 4 squares, 5, and 6. So you get the idea. We're just arranging. We could use square tiles. We could do it on square dot paper. But these are ways we can make rectangles. Okay, and it's important for your child to understand that a square is a rectangle, equilateral rectangle. So square is not a separate shape. It is a special case of a rectangle. Now, what if I circle the ones that I could only make 2 different rectangles for it? Notice 2, 3, and 5, I could only show 2 different rectangles for it. Those are the first 3 prime numbers. And so if you look at 2, 1 by 2 or 2 by 1, 3, 1 by 3, 3 by 1, 1 by 5, 5 by 1, each of these have 2 factors. 2, 1 and 2, 3, 1 and 3, 5, 1 and 5. Each have exactly 2 factors. Now, some of us learn prime numbers have itself and 1 as a factor, and that can be a little misleading, and I'll show you why in a second. But exactly 2 factors, exactly 2 rectangles I could make. Gives me some imagery for what I'm doing. 4 and 6, I had more than 2 factors. 4 has 1, 2, and 4. 6 has 1, 2, 3, and 6. More than 2 factors. Those would be called composite numbers. Okay? So more than 2 factors are the composite numbers. Exactly 2 factors are prime numbers. And we use prime later. We'll talk about prime factorization, writing a number where the factors are only prime numbers. So they will use this as they go up in the grades. So we got prime and composite, but what about 1? See, these dimensions are 1 by 1. It has only 1 factor, 1. So many would say it's not prime and it's not composite, because to be prime, exactly 2. To be composite, more than 2. So prime. So I hope that helped give some idea of types of numbers, but how we can take geometric looks at numbers to help build understanding with your children, to help give them the imagery that will help them move far beyond just that number computation recall level. Okay? I hope that helped. Please consider giving it a thumbs up if it did. Share with others. Please consider subscribing to the channel, and welcome to those of you who recently did subscribe. I appreciate it. It really does help the channel. It really does make a difference. Click on the notifications bell so you'll know when other videos are posted. And thanks so much for watching.